All right, types of slope. We are now finally to the point where we've arrived at the purpose of calculus. Any Joe Schmo, pretty much any math student from like middle school on can find the slope of a line, right? Everybody can find the slope of a line. Rise over run, y2 minus y1, everybody can do it. Only a calculus student can find the slope of a curve, because curves have slope. It's just different slope at every single point, but it still has a slope. So on a line, no matter what point you are, no matter where you are on a line, will the slope ever change? Not on a line. Okay, no matter where you are, on that particular line, the slope will always be the same. On a curve, depending on where you are, will the slope change? Okay, even if you change a tiny bit, what if you're like at 1 and then at 1.1? The slope changed, okay? Slope changed a little bit. So only a calculus student can find the slope on a curve. So that now we're like to the point, all right, we've made it. We've made it to the point of the purpose of being in calculus. All right, so let's talk about the slope of a line. All right, the slope of a secant line. What's the difference between the slope of a secant line and the slope of a tangent line? All right, that's the important question here. The slope of a secant line and the slope of a tangent line. A secant line goes through a minimum of how many points? How many points does it take to make a line? 2. You need a point that you're starting at, and you need a point that you're ending at, and you got to go through the both of them. All right, a secant line takes 2 points. Okay, we say that those are points f of x minus f of no, let's do a and b. I think that'll be a little bit better. F of a compared to f of b. Those are 2 separate points on a line. And so when you calculate it, it's y2 minus y1, that's f of b minus f of a over b minus a. Or in old-fashioned, when you first learned slope, it was y2 minus y1 over x2 minus x1. That is the slope of a secant line. It takes 2 distinctly different points, separated from each other on a line, and then you can figure out the slope. This is also called average. When you find the average slope, find the average rate, find the average anything, the word average assumes that you have, because you can't average things unless you have at least 2 of them, right? You can't average yourself with yourself. You need at least one other thing to average with. You need 2 or more to average. So when we talk about average, anything with the word average in it is going to be using that formula, the old-fashioned slope formula. All right. A tangent line, okay, is a straight line that touches a curve how many times? Once. Okay, a tangent line is a straight line, okay, linear line that intersects with a curve once. So for example, just a visual here, okay, you might have a curve that looks like that, and your tangent might intersect with it once, and it's going to skim off right there. Or if you found the tangent somewhere else, maybe your tangent was right here, and now the slope is different, and so it's going to look like that. So depending on where you are, the tangent line is going to skim off in a different direction. Those are all tangent lines. They only intersect one time. The difference in the slope of a tangent line and the slope of a secant line is one tiny little word, and it's the word limit. So the formula for the slope of a tangent line is still, leave a little space, f of b minus f of a over b minus a. So it's y2 minus y1. And what makes it a tangent line is that there's limit in front of it. Without limit, it's not a calculus problem. Without limit, it's a basic old ham-ram algebra 2, algebra 1 problem. With limit, it now becomes a calculus problem, and you can find the tangent slope of a curve. Now, in the limit, we have to have something approaching something. Okay? And what we want is that we want B to approach A. All right, what does that mean? So let me help you try and understand that. I'm going to redraw that curve I was working with here. All right, let's put point A right here. And let's put point B way over on the other side. If I connect point A to point B, that is a secant slope because they're far apart from each other. I can connect them, no problem. What if and we'll call that B1. What if I move B2 a little bit closer? Will that be the same secant slope if I connect A to that B1? That's going to be a little different. So if I connect those two, it's going to be a little different connected to those two. And then what if I move it a little bit closer, B3, and connect A to that? Okay, that's a little bit different. And then what if I keep backing up and I say, well, then here's B4 and B5 and B6 and B7. What are the B's doing? Getting closer. Use the words we use in limits. They are approaching A, and they're getting closer and closer. And B9. So all of these point values are getting super, super close. In fact, what will eventually happen? It will be, now, will they actually ever be the same? Okay, in limits, you can't ever get there, but you can get closer and closer and closer till where they're practically the same thing. They're practically going to be lying right on top of each other. If I could get my, BN in here, it would be so super close to A, or to just plain A, you wouldn't even be able to tell the difference. That is what makes it a secant slope. We call the space between them, the space between A and your final BN, we call that H. How big is H? Very, very small. How small is it? Approaching what? Will it ever be 0? Okay, but it will be so small, we call that negligible. It's going to be, the space between them is going to be so small that we can barely tell the difference between them. All right, so another way to write this slope of a tangent line is to use these 2 points, x plus h and x. Instead of a and b, we can say we're going to use those 2 points, we're going to use x plus h and x. And so if you do y2 minus y1 over the other two, it's going to become, instead of b and a, it's now going to be x plus h minus x, because it's the b part minus the a part. But the limit in front of that, what is h approaching? How big was h? Okay, so it's approaching 0. Okay, h isn't approaching x. B, we want h is the value between them, and we want that to approach 0. What happens in the denominator when you have h plus x? No, x plus h minus x. Okay, what can cancel out? The x's. And so a more simple way to write that is just to write it over h. Now I know that Ms. Price showed you that in HAM last year, and you called it the difference quotient. That is the slope of a curved line. That formula right there. Either one of these, you can use either one. You can use the b minus a, or you can use the h and x one. Either one is fine. They both get you the same thing. Just like you could use y2 minus y1, or you could use f of b minus f of a. They both do the same thing. All right, that is the whole premise of calculus, is finding the slope along the point of one curve. If secant is called average, this one is called instantaneous. So those are the words that you have to look for. You have to look for words. If you're looking for secant, it goes with average. If you're looking for tangent, it goes for instantaneous. If you're going for line, it's secant. If you're going for curve, it's tangent. And so always just be looking for which words to use. The words determine whether or not you have limit in front of it or not. If it's average, there's no limit. If there's instantaneous, there is. All right, so let's practice some problems of how that's going to go. And this is heavy on the algebra. If you like algebra, you'll like this. This is heavy on the algebra. All right, find the instantaneous slope. They also use the word rate, find the instantaneous rate, and that would mean the same thing. Along the curve x squared plus 2x at the point x equals 1. One of the biggest things, problems I see calculus students do is they focus on the number 1 and they just want to like plug it in somewhere. They get so excited about the number 1. That's actually the absolute last thing you do. All right, so don't get distracted by the number 1. First, you want to find the instantaneous slope. What, Ian? No. You have to prove it. I knew what you were going to ask. All right, so we're going to do our instantaneous slope. This one I'm going to do with the limit of h approaching 0. So we need to do f of x plus h, which is a little bit away from f of x. They're really close to each other, but they're not the same point. So we need to take the quantity x plus h and plug it into the function. And then we're going to subtract plain old f of x after that. Please be practicing good limit and equals forms. When I take x plus h and I plug it into the function, I'm plugging it into both positions for, that wasn't clear, plugging it into both positions for x. So it will be parentheses x plus h plugged into the square and 2 parentheses x plus h. So that's x plus h plugged into the function. Then I'm going to subtract the original f of x, which was x squared and minus 2x. The subtraction affects both parts. And the whole thing is over h. Now here's why I was saying it was heavy algebra. Now you're going to FOIL and clean up the mess that you made. So equals limit, and I apologize, I'm writing that 8x should not be there. It should have been an h. Somebody holler at me to make sure that I'm not doing the wrong thing. Thanks. All right, x plus h quantities squared in FOIL is x squared plus 2xh plus h squared. That's the FOIL. Then the distributing, 2x and 2h, and then minus the original f of x function. So you make a mess, and then you clean it up. So this is equal to, I'm still keeping consistent with my equal sign and my limit notation. So let's clean up this mess. What happens in this great big gigantic mess? Cal, let's embrace our algebra. X squared cancels out. Beautiful. What else? 2x cancels out. Great. Anything else cancel out? No. All right, but we are left with 2xh plus an h squared plus a 2h all over h. What does every single part of that problem have in common? An h. So we can divide the h out since they all have an h in common. Now you need a parenthesis because you've made a division. It's like factoring where you pull out an h. And we are left with 2x plus h plus 2. Now we can finally plug in the numbers. What are we going to plug in for h? What are we going to plug in for x? Now you can plug in your numbers. So you're going to plug in 2 times 1 plus 0 plus 2. The answer is 4. So that tells you that along this parabola, at that particular point, the slope was 4, the instantaneous slope. Instantaneous meaning at that point and at that point only, the slope was 4. Well, what if I said, well, what about the number 8? Or what about at the number 17? What are you still plugging in for h?
0.
And then you change what you plug in for x, but do it at the end. Any questions on that one? All right, let's try another one. All right, find the tangent slope. So there's that word tangent again, so we know we're using limit along the function 1 over x at x equals 3. By the way, if they don't ever give you a point for x, you still can do the whole thing and you'll just plug in h, and that will be the only thing you plug in is just h. So because it says tangent slope, we're going to use the limit definition. So the limit as h approaches 0. Now we start with plugging x plus h into the function, and then we'll subtract the original f of x all over h. So I'm just writing the definition so that we kind of start memorizing that formula. My first step is to plug x plus h into the function. So where does it go? Okay, it goes right there onto the denominator. So I'm going to have 1 over x plus h. I'm going to subtract the original function, which was 1 over x. And the whole thing is over h. Again, this is algebra heavy. So now we have to do some algebra, and we're going to make a mess before we clean it up. In order to subtract two fractions, what do they have to have in common? They need their denominators. So I'm going to make a mess, and then I'll clean it up. So my mess is these both need a common denominator. So 1 over x plus h needs 1 over x. And 1 over x needs 1 over x plus h. And they're all still over h. I know it's a huge mess. Let me write it, make sure I'm doing the right math. I need to multiply by x over x. Here we go. Got to make sure you're multiplying by 1. There's common denominators. So I'm multiplying the first one by x over x. I'm multiplying the second one by x plus h over x plus h. So my mess starts to clean up a little bit. I get x over x squared plus xh. That's the new denominator. Minus x plus h over the new denominator, x plus xh. So I have a new common denominator, and the whole thing is still over the variable h. All right, when I subtract, now that I have the common denominator, what will the numerator simplify to? And be careful about how you subtract. Negative h, because that negative affects both the x behind it and the h behind it as well. So I'm left with negative h over the common denominator x squared plus xh over the other whole denominator h. And the top h and the bottom h reduce. So I am now left with the limit as Mrs. Pfeiffer. I'm doing good. It's Friday. All right, h. Okay, now I've got negative 1 as my numerator and x squared plus xh. So I've cleaned it up all the way to that algebra. And now I can plug in what for h? 0. And what for x? 3. All right, so that's going to give me negative 1 over 3 squared plus 3 times 0, so negative 1/9. So that tells me the instantaneous slope along this hyperbola at that particular place is the number negative 1/9. Will it ever be negative 1/9 again? No, that's the only place it will be. Well, this has symmetry, so there's one other spot it will be, but okay, only one other time will it be negative 1/9. Okay, now let's extend this same problem. Write the tangent line. Write the equation. Both the tangent and the normal line. And remember that the word normal means what? Doesn't mean secant. Normal means perpendicular. So we need to know what point this tangent line is skimming off this hyperbola. Picture the hyperbola. Picture the hyperbola. It looks like this. We're at the number 3. 1, 2, 3, right here. What is the position of that point right there on the hyperbola? 3 what? Well, the hyperbola is 1 over x, so 3 comma 1/3. So that's the point that this tangent line is going through, and we just determined that the slope right there, skimming right off of that, that the slope is negative 1/9. So I can write the tangent line. So the tangent line is y minus 1/3 equals the slope of negative 1/9 and x minus 3. Does anybody remember the name of that format for a line? Point, slope. That is as far as you have to go. You do not need to simplify. You do not need to distribute. You can leave it in point, slope form. That's the tangent line. How do you make a tangent line? How do you compare it to the normal line if normal means perpendicular? Does a perpendicular line still go through the same point? Okay, and what does it have different? So it's still going to be y minus 1/3, and what is the value of the slope going to be? Positive 9. It's the opposite reciprocal. So you do not have to do a ton of work for those. You don't have to simplify. You just have to know what the point was along the original function and take the tangent slope that you figured out previously. Yeah?
You got the point because of the 1 over x.
Right, the function was 1 over x. Right. Okay, last equation. Can you make a tangent line at x equals 0 for the following function? Negative x if x is less than 0, and x squared minus x if x is greater than 0. That's the question. Well, to answer the question, you have to know what the slope is along both sides. On the left side, bless you, what's the shape on the left side of this picture? It's a line. Everybody knows the slope of a line, right? Okay, so the left slope along the line is, and what is the slope along that line on the left side? Negative 1, because it's just negative x. Now the right slope, what shape is that? That's a parabola. And so the right slope along the curve is the following formula. Limit as h approaches 0 of f of x plus h minus f of x all over h. You're going to have to calculate what the slope is going to be. What will you plug in for h when you're done? What will you plug in for x when you're done? Also 0, because that's where I'm looking at. I'm looking at x value. And what, if you could make a tangent line, what should be true about the results?
Rachel Sturton, Bella,
What do you think it should be equal to?
and Sophia Moreno, please report to
It should be equal to the left slope. The left and the right slope have to be equal to each other. Otherwise, you can't do it. You say, no, I can't. So the answer is yes or the answer is no when you're all done.